Chapter 3, Section 2, we're going to look at some more concepts dealing with quadratics and parabolas. And so let's start with this idea of the axis of symmetry. So what is the axis of symmetry of a parabola? Well, it's basically the line you can see here in red that divides the parabola into two equal sides. So there's this idea of symmetry that the right-hand side is the same as the left. It's like a mirror image, more or less. And the one thing you'll notice is this happens to go right through the HK, the vertex. So we learned about the vertex form, A, open parenthesis, x minus h, closed, squared plus k. So that means the axis of symmetry is always simply going to be x equals whatever h happens to be. So it's easy to find the axis of symmetry if you know the vertex, because it's basically x equals the x value of the vertex, also known as h. And so looking at example 1, we have a parabola that is in vertex form, and it says label the vertex. We're going to graph it, label the vertex, and the axis of symmetry. So here we know that this thing opens down. We know that the A is -2, so it opens down. It's a little bit more wide than the parent. And then the H, remember, is -3. It's the opposite of what you see in the parenthesis. And then the K is 4. So that means my vertex is located at -3, 4. So if I go plot the point -3, 4, I know it opens down. I know it's a little bit more wide than the parent. I could figure out exactly what it looks like, but that's good enough. The -2 actually is all this idea of slope. It goes down 2 and over 1. You can plot that point, and it gets a little wider as we go down, but that's it. And then the axis of symmetry is just x equals, it's a vertical line, x equals, and then whatever the h is, so -3. And so we can find these other points by, plugging in values, but basically that's it. If we're in vertex form, it's a very simple process. There's another form of a quadratic that you're probably more familiar with. It's called standard form, and it's in the form ax squared plus bx plus c. So there's some value a, b, and c that you can use to graph. It's not as clear cut as vertex form because you don't know the vertex, but you can see they expand some stuff out to kind of show you how this all works. But here's what we can draw from this observations. A is going to be a in either one. So whatever your a was up here, -2, if you expanded it into this form, it'd be the same, -2. The b, however, basically has the form -2 times a times h, or if you rearrange this, the h is always going to equal -b over 2a. Now this is a great thing to know because that's also the axis of symmetry. So h, our x value of the vertex, is -b over 2a. Therefore, x equals -b over 2a is going to be our axis of symmetry. And then the c has something to do with the moving up and down, but not a direct correlation. So it's this idea of a h squared plus k. So the easiest way to look at this is c is basically the y-intercept, is what it amounts to. So if we're in standard form, our graphing is a little different, okay? What do we know? We can know if it opens up or down, okay, based on the value of a. We can know the y-intercept, that's 0, c, because c is the y-intercept. And then to find the axis of symmetry, we're going to use -b over 2a. So x will equal -b over 2a. And then, of course, if a is positive, the thing opens up. If a is negative, it opens down. If you want to find the actual hk, the vertex, then you will take the -b over 2a. That'll be your x value of the vertex. And then plug it into the actual function to find f of that. So this would be your k. So this is h and this is k, and that's how we can find them when we're in standard form. So let's take a look at example 2. All right, so we've got 3x squared plus 3x squared minus 6x plus 1. So my a is 3, my b is -6, and my c is 1. And then a is greater than 0, 3, so it opens up. So let's first of all find the vertex. So let's use -b over 2a. So that would be negative, and then -6 over 2 times 3 would be -6 over -6, also known as 1. So that's the h, 1 comma something. To find the k, the other value of the vertex, let's plug in and do f of 1. So when you plug that in and do your math, you get -2, because basically 3 times 1 squared minus 6 times 1 plus 1 is -2. So I've now found the vertex is at 3, -2. I could plot that point. I know my y-intercept is 1, so I could plot that point and then use symmetry. So this is the axis of symmetry, so you go over 1, you go over 1, there's your other point, and you can find other points, but that's actually good enough to graph this thing, okay? So -b over 2a is the x value of the vertex, also known as h. To find k, you plug in that x or that h value and find k, and then use the axis of symmetry in the y-intercept, which is c in ax squared plus bx plus c. And you can find some other points using symmetry. All right, if you haven't noticed, that vertex is always going to be a maximum or a minimum. It's going to be a high point or a low point. And now that we know the form ax squared plus bx plus c, and we also know that the x value of the vertex, which is also known as h, is equal to negative b over 2a, this is also a method to find your maxes or your mins. All right, so if the a value is positive, we know the parabola opens up, so that makes this a minimum. If the a value is less than 0 or negative, it makes this high point a maximum. And then to find the actual point, we're going to use negative b over 2a. Once we find it, we plug it in and solve for y, and that will be the y value. So that's how you find your k, if you will. All right, so as we take a look at this, find the minimum and the maximum values of this particular function. It's a quadratic. Describe the domain and the range, okay? And then where the function is increasing and decreasing. All right, so looking at the form, the a is 1/2, the b is -2, the c is -1. So that's our information we need. Because a is greater than 0, that means this thing opens up. So what does that mean? It means that when you graph it, this is going to be a low point or a minimum. So there's nothing below this point. That's going to apply to the range, okay? And so let's find this point. We can do it in the calculator, but let's do it by hand. X equals negative b over 2a, so that'd be negative, and then b is -2. 2 times a is 1/2. So we get basically 2 times 1/2 is 1. And so we get negative is positive 2 over 1, or 2. All right, so 2 comma something. To find the something, let's do f of 2. So taking a 2 and plugging it into the original function, 2 squared is 4, half of that is 2. 2 times 2 is 4, so 4 minus 4 is basically, or excuse me, 2 minus 4 is -2. -2 minus 1 is -3. So it occurs at the ordered pair 2, -3. All right, now that's a minimum. So that means the range, there's nothing below this y value. So the range of this function is going to be from basically everything bigger than -3. So y is such that y is greater than or equal to -3. Okay. And the domain for these are just going to be all real numbers because you can plug in any x value you want to. There's no restrictions. And then the decrease, well, it's from 2. If you're going from the left until you get to x equals 2, it's going down. That's a decrease. And then from 2 to the right, it's going up, increasing. So basically everything to the left of x equals 2 is going to be a decrease. Everything to the right of x equals 2 is going to be an increase. All right, here's a third form of how you can write a quadratic. It again is going to have the a, and the a is the same a we've looked at. X minus p, x minus q. P and q are going to be the zeros of the function, okay? So basically this has been factored is more or less what it is. So these are called the intercept forms because it's a quick way to find the x-intercepts because all you do is set the factor x minus p equal to 0 and solve, or the factor x minus q equal to 0 and solve. All right, so what does that mean? If this is a 0 and this is a 0 because of symmetry, the point right between them is going to be the basically x value of the vertex, or the h. So if I can take p and q and add them up and divide by 2, that's basically averaging them, you would be finding their midpoint. So that's how you're going to find the x value of the vertex, also known as the axis of symmetry. All right, so as I look at this one, a is -2. Well, that means the parabola is going to open down. Then to find where it crosses the x-axis, I set x plus 3 equal to 0 and solve, and I get -3. I set x minus 1 equal to 0 and solve, and I get x equals 1. So basically, I now know at 1 and at -3 it crosses. I just don't know how high it goes. So to find that, I'm going to basically find the midpoint of these. So add them up. -3 plus 1 is -2, divided by 2 is -1. And then I'm going to take that x value and input it into the function. F of -1, do your math, is 8. So that generates the ordered pair -1, 8. So at this point, I got a great graph. I got the vertex. I've got the x-intercepts. Go ahead and draw the line down, and you can see what it looks like. So a different form. So 3 different forms we're looking at in this lesson. We're looking at intercept form, this guy right here, where I find the x-intercepts. We're looking at vertex form, which the h and the k we can find easily, and then standard form, ax squared plus bx plus c. Whatever form you're in, you now have 3 different ways to sort of attack each of these problems. Like here, this one would cross at -1 and at -5. So I'd find the midpoint between -1 and -5, and that would be the x value of the vertex. This one here would cross at 6 and cross at 2, so I'd find 6 and 2, add them up is 8, half of that is 4. And so it would be 4 comma something. To find the something, plug in the 4 here, and you can find that, and you'll have your vertex. All right, now putting that all together, there's a lot of different situations in life that are quadratic. Anything that deals with gravity is quadratic. So here's an example where apparently we're going to hit a golf ball, and what goes up must come down. So of course we know that's gravity. And so we have our shot, and what we can see here just by looking at the picture is that it's going to travel basically 100. Okay, I guess that's 100 yards. Okay, yeah, 100 yards. And it reaches a maximum height of 25 yards when it's halfway there, which is 50. And so I've got all my information, but here is the function, okay, modeled. And excuse me, this is one function, and this is a second function, and they want to know which one goes higher. So I already know that this one reached a height of 25. Not so sure about this one. But here's what I do know just by looking at it. If I set this equal to 0, I would get 80. If I set this equal to 0, I would get 0. So this one travels 80. So the midpoint is going to occur halfway between 0 and 80. Okay, halfway between 0 and 80 is 40. So it's 40 comma something. So when I plug in the 40, it travels a height of 32. And I can see from this one, it traveled a height of 25. So which one's higher? Well, obviously the 32 is, okay? And so you can work through this problem at your own leisure, but basically that's what it amounts to. Now to find the max and the min, here's the thing that we cannot lose sight of. You can always go to y equals, and you can graph some quadratic, whatever it happens to be. It doesn't even matter what form it's in. So we graph that guy right there. Let me take my window down just a little bit so I can see a little more of this guy. All right, and if I wanted to find this vertex, I can use the minimum feature. Second, trace, and then minimum, number 3. And I would hit enter because I'm on the left of it, and move to the right of it, hit enter, and then the third enter finds it. So this would be read as just 1 comma -11. So the vertex occurs at 1 -11. The axis of symmetry is x equals 1, and so on and so forth. So a lot of this can be done in the calculator if you need to, but you want to try to do it by hand first if possible.